Let's do the example from the last tutorial in the calculator. So remember that we can, well, let's do like this. Let's open a graph page first. Let's just enter the function x to the power of 3 plus x squared minus 6x. Let's zoom out a little bit, or actually let's go to window settings. We can see that we cannot really see the maximum up here, so I just want to change the y max to be 10. Then I'm gonna click OK. Now I can see the maximum and the minimum here. Let's draw the derivative of the function in the same graph. Let's do it like this. Remember, we can go to a calculator page. Since we already did function f1, we still have f1 defined. So if I just type f1 of x, you see that we have the function here. Now I want to define the second function f2 of x, not equal to, but the define symbol, which is colon is equal to. And instead of just by hand figuring out or manually figuring out the derivative, we can just go to menu, calculus, derivative, d dx, because x is the variable, and then we just write the function here, which is f1 of x. And then we have defined the function f2 as the derivative of f1. Let's just make sure and see that everything was okay and it's correct, and that is correct. So f2 would be 3x2 plus 2x minus 6. That's fine. Okay, let's go back to the graph page and go to tab and go up a step. Here we have the f2 function. Let's press enter to draw that graph. I'm going to move it up here. Now we can see the connection between the two. Okay, so the blue one is the actual function. Here the derivative should be 0. Let's go down here. At this x value, we can see that the black graph, it's here on the x-axis, so the derivative is 0. Also here the derivative should be 0 because we're at the minimum of the function. So let's go up here until we meet the x-axis. We can see that the black graph, the curve is on the x-axis, so this means that the derivative is 0. Okay, so let's draw a couple of different functions and its derivative to see if we can discover the connection between them. Okay, so let's do like this. Let's do this function. Should be easy. Y is equal to 2x. Looks like this. Now, before I draw the graph of its derivative, how should it look like if I draw it in the same coordinate system? So we know, of course, that the derivative of 2x is going to be 2. So the derivative is going to be 2, and it doesn't matter what x is, it's always going to be 2. So y value 2, 2, 2, 2, value 2, y value 2. So it's going to be a straight line. Let's see if we're correct. Let's go to calculator page, define the derivative as calculus the derivative d dx of our function f1 of x. There we go. Let's go back to the graph page. Now tab, go up, the derivative of f1, and here we go. So we see the function, and here's the graph of its derivative. And the derivative is going to be 2 always, because it doesn't matter where we are in the curve, it's increasing at the same pace, so it's always going to be 2. Okay, the slope of the tangent in any point is going to be 2. Therefore, the derivative is always 2 for every x value. Let's try one more. Let's draw this function. X to the power of 2 minus 4x. We have a minimum here, so before we draw the graph of its derivative, let's see if we can figure out how it should look like. So we know that derivative here in the minimum is going to be 0, so it's going to cross the x-axis here where x is equal to 2. If we keep going to the right, from to the right of x is equal to 2, the graph is increasing. Okay, so we should have a positive derivative here. So here it's going to be 0, and here it's going to be positive. Okay, and if we keep going, if we go to the left of x is equal to 2, well, we see here that it's decreasing until we get here. So we should have a negative derivative to the left of x is equal to 2. So it should be negative somewhere down here, 0, and then positive. Okay. And what is the derivative of this function? Well, it's going to be 2x minus 4. So if we know how to draw the graph by hand of a function 2x minus 4, we could do that. Let's go to a calculator page and define f2 of x as the derivative of our function. Derivative dx of the function. Our function is f1 of x. Done. Let's go back to the graph and tab and go up. Here we can see f2. Let's draw the graph. And there we go. Just as we suspected. Here we have a minimum, so the derivative has to be 0, which is true. And when x is greater than 2, it's going to be positive derivative. Okay. And then to the left of x is minus 2, the derivative has to be below the x-axis, which means it has a negative value. Here it's minus 1, minus 2, minus 3, here it's minus 4, minus 5, etc. So do this with a couple of more functions. Just draw the function and then define the derivative of the function in another function and draw the curve of that function and see if you can see the connection between the actual function and its derivative.